Hi everyone, this is Team 7 and we have implemented the project Job Search System using Semantic Web Engineering. So what's the problem we are trying to solve? With the increasing trend in online recruitment and with development of platforms like LinkedIn, Glassdoor and Indeed, companies post enormous job postings every day on these platforms. Since there are many platforms, users will have to log into each one of them and check for the desired jobs. This can be a very tedious process. We want to create a platform where all the job postings are available to the users in one place and provide flexibility of filtering the jobs based on the metadata that are used to tag jobs. We are collecting the data from open source sites like Kaggle and Google open source data. For the purpose of this project, we have collected job data from Indeed and Monster.com. The major challenge is that the data is heterogeneous and there is no consistent structure to the data. Through semantic transformation, we are solving the issue of a data heterogeneity using resource description framework, that is RDF format. This approach offers better relevant data over the existing job recommendation systems. So how should we do that? The first step in the project is to develop an ontology after looking at this data by noticing similar fields and attributes in them. After creating an ontology, we'll link that to the linked open data. We'll use Apache Gina to build triples ontology and query using SparkQL. High-level design and approach. An enormous amount of content is generated every day. Maintaining and retrieving relevant content is a challenge. So this paper which we are referring to is social media event detection. The problem of detecting social events using the Flickr and Facebook website data and by identifying photographs as events has been discussed in this paper. The solution is implemented by using metadata fields about photographs like photo ID, title, tags, description, date, time, and geolocation. So this paper also explains how ontology for these events domain is implemented and events are detected using Prodigy. We are trying to use a similar approach as used in this paper to solve the problem with job posting platforms. We have metadata about the job postings from LinkedIn and Monster websites like job title, location, salary. So now the creation of ontologies will be discussed by Raghavan.
This is Raghavan. I'm going to walk through the ontologies that we have created. We have created three different ontology files: companies, jobs, and locations. Now let's start with companies file. We have two different classes, company and jobs in company, where jobs created are tied to a company by this property, object property, that is company has jobs. When a job is created, we need to know which company created the job. That's where we are using this property. Similarly, company details we are storing using data properties. CEO, we can store the name of the CEO. We are having company name and company ID, and there can be reviews about the company written by the employees or people who interviewed, and we also store the number of employees working. Coming to jobs file, we have five different classes. This is a jobs class where we have a bunch of object and data properties. When a job is created, we need to link it to a company. Similarly, when a job is created, we have to link it to a location where uh, the posting is open, and that is by using this property where posted by has domain job and range as company, job company. That means we are tying a job to a company, and similarly located in is we are tying a job to a location. Similarly, we have industry class where we have a bunch of subclasses, as well as for job type where we are having three different types of jobs that might be available. That is using this object property for the job type, and for industry it belongs to industry. For data properties for a job, we are storing the application link using which user can apply. We also have company that posted the job. This is domain is job company and range is string. Similarly, a job can have a description, salary, title, and location name is for location where we are storing the name as a literal or a string. Um, and we are also having a posted date. Coming to our last file, which is location, we just have location here, which has three subclasses: city, country, and state. And we have um, two properties and two inverse properties. I'll start with belongs to a country, where a state belongs to a country, but this is inverse of has state. Similarly, we have belongs to state, where our domain is city and range is state, and which is inverse of has city, where a state can have city. And data property, we are storing cities, latitude and longitude. Then we are giving an ID and then storing the name of the location. So these three are ontology files.
So this is Sally from Team 7 and I'll quickly give you a walkthrough about the project structure and the setup. So this is, we have launched the three EC2 instances on Amazon AWS platform to host the three datasets that are there in our project. So this is one of the instances in my account. I've opened all these three endpoints here in my Chrome. So on this first EC2 instance, we have hosted the company's dataset. A simple query like subject predicate object can show the data that is there in this particular data set. Similarly, on second instance, we are hosting city and locations dataset, and on the third one, we are hosting the jobs dataset. Here you can see the data in this particular dataset. After setting up the physical server to host the datasets on AWS EC2 instances, we developed the Java application to query the data from datasets. So this is our Spring Boot application to implement the REST API calls. Under the source main Java, we have a package com.ser.swe where all our Java files are. So jobs application.java is where the main class is. In ontology.java, we are setting up all the properties. For example, we are setting up EC2 endpoints here. And in SparkQuell query and in SparkQuell queries.java, we have written all these query for fetching the data from these data sets. So for example, we have implemented filter queries and some visualization queries that we have implemented on our front end. Talking about front end, these queries will be running on physical server and the data is written to this Spring Boot application, and then this data will be routed to the user interface, so which will be rendered on the interactive format. So this is the app.js file, which is a JavaScript file that we have written for our front end implementation, and this is the HTML file that is here in the front end project. We have also added the readme file where all the instructions are there to run the program on your local machine. Thank you.
Hi, I'm Pariksha, and I'll be giving the demonstration of our job search application. As explained previously by our teammates, we are hosting front-end application using Node.js and backend using the Spring Boot APIs. For the purpose of simplicity, we have hosted our application on the Amazon EC2 servers. So this will be easy for us to create as well. So the website can be accessed in this location using this link. For this website, we have 5 filters, which are basically the location filter, the company name, job title based search, industry filter, and the last one is the job type, which is the full-time, part-time, and the internship one. So let me put a filter here as Phoenix as the job location, and I chose like full-time as the jobs. So I should get all the full-time jobs that are present in Phoenix location. So here we get all the jobs from the Phoenix location, which are full-time. So I will apply more filters now. Here, let me check with Wordpedia, with systems admin. The industry is finance. And go with part-time jobs here. I do a search and I get, yeah, here there is a job which matches my description with matches my search criteria. The Wordpedia has a system administrator 4 job, which is a part-time and it is in the finance domain. Also, I get here the the word company details like the CEO, the number of employee job posted, the finance number of jobs in the finance domain, number of part-time jobs in the database, number of jobs that contain system admins as their title. So I do the same thing here for the local host because I want to show the queries here. So when I do the search for Phoenix and full-time roles, you can see in the database the visualization queries that are getting generated as well as the search query. The search query with Phoenix and full-time as the filters, and the visualization query with full-time as the filter and Phoenix as the filter here. So these two, the nearby locations are given as the data visualization query, which returns the results. So with Wordpedia, uh, system admins, and let me go with part-time. I can see Wordpedia here. So again, here you can see a large number of queries getting generated, which is the visualization query here for the this is the company filter where I can see Wordpedia, and I have other visualization like systems admin and the search query. Yeah, for this project, Raghavan worked on the ontology of jobs, data refining, and hosting on the servers. Parikshit, worked on the ontology of companies, building front-end application and hosting it. Sayali worked on the ontology of locations, creating Spring Boot backend service, and Rishika worked on the relevant data gathering and the documentation part of it. Thank you.